Using Le Chatelier's principle, let's predict how the concentration of H2 will change when the following changes are occurring. For A, we're going to add CO2, which is increasing the concentration of CO2. If we increase the concentration of CO2, the equilibrium will shift away from the increase, so it would shift to the product side. Therefore, the molarity of H2 would increase. For B, we are going to add CO2, which is effectively increasing the concentration of CO2. If we increase the concentration of CO2, the equilibrium shifts away from the increase to favor the reactants, and therefore would consume H2 and decrease the molarity of H2. In C, we are going to remove H2O, which effectively decreases the molarity of the H2O. If we decrease the molarity of H2O, the equilibrium shifts towards the decrease. Therefore, we'll use up H2 and the concentration of H2 would decrease. And lastly, we are going to remove CO2 and account for this in terms of the reaction quotient. By removing CO2, we show a decrease there. Shift towards a decrease is what Le Chatelier's principle would do. As we shift towards the right, the molarity of H2 would increase, and accounting for this in terms of the reaction quotient, in order to shift towards the right, Q has to be less than the equilibrium constant for that to happen.